video podcast is going to contain information on consumer optimization. So, when we look at consumer optimization, we're looking at two different equations. We're looking at our income equation, our budget constraint, which is I equals px times x plus py times y, and our utility function, which is utility is some function of both quantity x and y. So just to go through the variables again, we have I, which equals income, px, which is the price of x, py is the price of y, x is the quantity of y, y equals the quantity of x equals the quantity of x, and y equals the quantity of y. Also, later we'll get into x starred and y starred when we're looking at our answer, and this is the optimal quality, optimal quantity of x. This equals the optimal quantity of y. So let's do an example problem to try to help you guys get how to solve these consumer optimization problems. To start out, I'm going to tell you some information, and from that information we're going to go through and solve the problem. First, we're going to start with our income. In this problem, our income is going to start at $1 million. And we also know that the consumer's utility function is modeled as the utility of x and y equals the log of x plus 2 log of y. Now, to solve this problem, we have to know our constraint, which is the budget constraint, which we know I equals px plus py. And we also have to know how that relates to, how our utility equation relates to our budget constraint. So, we know that if a utility curve demonstrates diminishing marginal utility, then the optimal point is going to be where the budget constraint is tangent to the indifference curve. And that happens when the marginal rate of substitution, which equals the marginal utility of x over the marginal utility of y, equals the slope of the budget line, which is px over py. So to solve this problem, we're going to have to find the marginal rate of substitution, which is the marginal utility of x over the marginal utility of y, over px py. So, how do we do that? First, we find the marginal utility of x, which is the derivative with respect to x, 1 over x. We find the partial derivative of y, which is 2 over y, and then mux over muy. We have some algebra over here. It simplifies to y over 2x. So we know that this is mux over muy. So it's over our marginal rate of substitution is y over 2x. And we know to solve this optimization problem, y over 2x is going to have to equal px over py. So we set this y over 2x equals px over py. And with some algebra manipulation, we have the price of y times the quantity of y equals 2 times the price of x times the quantity of x. Let's solve for y, which y is going to equal 2 times the price of x times the quantity of x all over the price of y. Once again, that's just some simple algebra manipulation. You can go through that again to make sure, but that's what it turns out to be. So now we know that what y equals in terms of relative prices and how it has to fit on the budget line. So now we're going to take this variable that we solved for and we're going to plug it into the budget constraint. So we have y, we're going to plug it into our budget constraint, which is I equals px times the quantity of y plus py times the quantity of y. Px times the quantity of x plus py times the quantity of y. So we plug that in, we get I equals the price of x times the quantity of x plus the price of y times what we substituted in for y. So you'll see that these two py's will cancel, so those go away, and then we're left with 2px times x. So that reduces to income equals 3 times the price of X times the quantity of X. So this is now our optimal bundle, or optimal amount of X. So we label this X star, and we solve for these constants. Px is going to be a constant, and I is going to be a constant. I actually we're given as 1,000,000. So we divide out the 3 of price of X on both sides. So we get X star equals I over 3px. And since we're given the income in this equation, the optimal quantity for X star equals 1,000,000 over 3px. Once we have this value right here, which is X star, we can plug it into this equation right here to find Y star. Y star equals 2,000,000 times 3 times, divided by 3py. The px's will cancel there and there. 2 times 1,000,000 divided by 3. So if you look at that, something interesting to see that your optimal quantity for X is not dictated by the price of Y. You can look at that over here. The optimal quantity of Y is not dictated by the price of X. And that has solved your consumer optimization problem for the utility equation log of X plus 2 log of Y. You can solve this with lots of different equations. So if our consumer's equation was X plus Y or xy to the 1/2, there's lots of different equations that could have gone with this. I chose this example. I think you can go through it and most other examples, and this will help you relate this concept to your homework. So this was consumer optimization and how to solve it. So go through the steps again. You get your income constraint, your budget constraint, then you get your utility curve, you get your equation for it, you find the marginal rate of substitution, you set that equal to px over py, and then you solve for a variable and plug that back into the budget constraint. And then you take that, what you solved for, and plug it back into your constraint up here, and that will solve you for X star or Y star, which is your optimal bundle.